So, welcome back. Today I want to go a little bit into some basics really. I think for the content I plan to do, it's necessary to make sure that people are on the same page really. We are all coming from different backgrounds and have different depth of knowledge. In this video, I want to quickly go over some basic stuff really that's needed for future videos. I will show you how to set up a Ubuntu cloud server, how to secure this server, how to install Caddy as a reverse proxy, how to install Docker, and how to install Portainer to manage Docker containers. This kind of setup is an easy way to get started with microservices or services in general that help an e-commerce business to get better at the technology side. In future videos, I will go deeper into different services like alternatives to Google Analytics or email automation or automation in general. For these kinds of videos, I will always refer back to using Docker containers really. So see this video a little bit as a fundamental one where I show an easy setup with Ubuntu, Docker, and Caddy as a reverse proxy to get things set up in an easy way really. So what we are going to build today really is a standard Ubuntu installation on a cloud server. That's usually a one-click install and should be the same for any cloud provider. What we'll do is we will install Ubuntu and we will make sure the installation is secure and reliable. On top of Ubuntu, we install Docker as a utility to run different services in containers. That means that the services are running in isolation and are very easy to move around and to port to other systems and so on. You will see that later on how easy that is really. As our first container, we will install a tool named Portainer. That's basically a web UI for managing the Docker daemon that's running on the server. That makes it easy to manage Docker containers in a graphical environment. And of course, we need to answer requests and route requests to the various services from the outside world. So we will also install a reverse proxy. In this case, we install Caddy, because that's very easy to manage and that will do a lot of things automatically. For example, when you set up a subdomain for a service you are using, Caddy will automatically take care to get SSL certificates so you can offer a secure connection. The reverse proxy will actually be between the open internet and our server. So it will basically route dependent on how the domain is set up or which domain it is called. It will route to the appropriate service that's running on Docker and make sure that the communication between the outside and the inside is going quickly and easily. The commands I'm showing here will be basically the same no matter if you're using macOS, Linux or Windows. If you're using Windows, please make sure you have a Windows 10 with one of the latest patches or Windows 11 because both of these versions support the same commands as Linux or macOS really. At first we need to generate a new key pair and that's done with the SSH keygen command. It will ask me where to put the key file really, so I will just select my home folder and usually that's the .ssh folder where the keys go into. In this case I'm gonna name this one Cloud Demo. I've tried this before though, so it exists already. I would just override it. You can set an optional passphrase that's independent really from the user login on the server. That's a passphrase that's needed to actually use this key. Usually that's not necessary really. So we hit enter and now our key is generated. And now I want to quickly set up a new instance of a Ubuntu server really. In my case, I've chosen the cloud provider Hetzner. It doesn't really matter which one you choose because basically they are all very similar in pricing and functionality. So I will just add a new server here. I will choose Ubuntu 2204 and For the machine, I will just go with something small for now. So we take 2 CPUs, 2 gigs of RAM. And most cloud providers offer the possibility to set a public key at server creation. That has the benefits really that you can log into your server from the start without even knowing the root password basically. What we can do here is to get back to our terminal and get the contents of the public part of the key pair really. So that's basically this string here. And now we can just paste our SSH key here and it will be automatically installed on the server when it's created really. And the other stuff is not really necessary. I would just name this cloud demo and go and create the server here. As you can see, it has already a public IP address really, and I'm going to copy this one. For this tutorial, I want the server and the management part for the different services to be available over the internet. And it's of course more comfortable to have assigned a domain name really to this service instead of entering an IP address each time. So I will just head over to my domain provider, which is GoDaddy in this case, and set a new record. And this should be an A record. And I put this to CA for container administration and point to the IP address of my server and set the time to live to 600 and save this one. I'm doing this at the start because DNS entries can take up to 48 hours to be populated on the internet. So I will do this as early as possible now. So when we are further on in the video, we don't have any problems reaching the subdomain we just created really. So let's have a look at the server. The server is up and running. What I'd like to do now is to make a little setup for our SSH connection to the server. So I will just open up a file in my SSH folder named config, and in my config file I can kind of make a shortcut. So I named this shortcut cloud demo. I put the IP address of my server. The user for now is root to log in, and I say that my private key is in my home folder .ssh cloud demo. So if I save this file now, so when I go back to my terminal now, I can just go for SSH and then say cloud demo. This will ask me one time if I trust the remote server I want to connect to, so I will just say yes. As you can see here, we are on Ubuntu 22.04 long-time support. So the first thing I would like to do is to create a user account. Right now we are logged in as the root user, but from a security standpoint it's much more secure if we set up a standard user and give this user the possibility to execute root commands and completely forget about the root user itself. Actually, I do not plan to ever use the root again, so let's do this. We go for add user and my username, and for now I would just do simple password, and it will ask for some details. That's totally optional. Yes, that's correct. As I said, I want this user to have admin privileges, so we need to add it to the sudo group. That's how it's called in Linux. So we clear this out and say user mod for modify the user, and we add it to the group sudo and put our username here. And now we check if this has worked. So you can see my user has a group named after my user, and it's also in the sudo group. Now we can switch over to our user, and I want to prepare the home directory of my user for SSH connections in order to let my user log into the server with SSH. I will quickly change to home and my username, And as you can see, this folder is almost empty except for some hidden directories. What we do now is we create a folder .ssh like you've seen before on my local system here. And with this, we make sure that only my new user has access to this folder. Now we can exit the session of the new user and also exit from the remote connection to the server. As the new user is set up, we can just copy the public part of our key pair onto the server so it's available for the user. What we do is we take the scp command and go for .ssh, the cloud demo.pub for the public key, and here we authenticate to the server. We say, okay, we want this user at this IP address and we want to copy it to our user folder for now. And now it will ask for the password. So I will just give the password we just assigned to the user. Now the public key has been sent to the server, and right now it's just lying around in the home directory. So we can just connect back to the server with our username, enter our password. The SSH server requires a file named authorized keys in the .ssh directory, and this file can contain multiple keys for multiple people, for example. And in this case, we will just have one key for now. It could technically hold multiple keys, really. So what we do now is we append the contents of our public key file to the file in .ssh named authorized keys. And as you can see, when we go to .ssh, as you can see, the contents of the public key file is now in this authorized keys file. And if we head back here and have a look, we still have the public key file, and we can just remove this one so the directory is empty again. And now I would like to make the SSH server a little bit more secure. For this, we need to edit the file sshd_config in the directory etc ssh. For this demo, I will just choose the nano editor because that's installed on every system and it's much easier to handle for most people than Vim or VI. As you can see, I want to open this file with the sudo in front of the nano command, and this will basically open the file as admin so I can edit it. So just enter my password. And now I have my file here, and I will just look up for what I need. So I want to go to this line which says permit root login, and this has been commented out, and I want to explicitly put this to no. So this will prevent the root user from even connecting over SSH into the server. That's an extra layer of security, really. And now we look for password authentication. And also on this one, I will just say this goes to no. Now we look for use PAM, and we also set this one to no. And now we can just exit with Control X, and we say yes and save our file. To apply our changes, we need to restart the SSH service, really. So this works by entering sudo systemcontrol restart SSH. And now the SSH service is restarted. And before we log out of this session, I want to open up another terminal and check if our changes are reflected and if we are still able to connect to our server, because it's very easy to do a mistake and have malfunctioning configuration. We don't want to be locked out of our server, really. So at first we try to log back into the server with the root user. And this is as expected because we said our root user is not allowed to log in. The second test I do is I will try to log into the server using the key file we gave to the cloud provider in the start and combine it with the root user. And as you can see, this is also denied. So there's no way really for the root user to get into the system right now from a remote connection. My third attempt is my main user. I will try to log in with the password, and this also fails, of course, and that's just fine like this. And my final test is to try to connect to the server with my main user using the key pair. And this works. So everything works fine now. Now we can, of course, just exit this session here. Delete this pane. To make it a bit easier, I will just update my config here to my main user. So I can just use the shorthand to log into my server. Just exit again. And now we say SSH cloud demo, and this is working now. As I showed you in the graphic in the start, I want to install the reverse proxy, basically handling HTTP requests and forwarding these to the various services we have running. So what I would like to do for now is to set the firewall to only enable 3 services. That would be HTTP, HTTPS, and of course SSH. To do this, we just take the command sudo ufww allow and make SSH, the prompt for my password, and we will go for HTTP and for HTTPS. And now we can just enable the firewall. So before I execute this command, there is of course a crucial part here really. We are logged into our server with SSH, and if for any reason we would have forgotten to allow the SSH connection through the firewall, we would lock us out of our system really. So please, when you follow this video, make sure that you allow SSH. And here it will tell me, of course, that this can disrupt SSH connections, but we are confident this will work. And now we can have a look at this one. And here we can see that the ports 22, which is SSH, and the ports 80 and 443, which are HTTP and HTTPS, are enabled. The next part I want to install is Caddy as a reverse proxy. Caddy is not available in the standard packages of Ubuntu, so we will just follow the standard documentation of Caddy and just copy and paste the commands you can find in the documentation. I have linked a blog post in the description below where I have written a little bit about the different steps, and I have also all commands as copy and paste, so it's easy to follow really for you. This is a brand new installation, so we haven't installed any additional packages and haven't done anything really to the systems. So we will just update our package repositories for Ubuntu. And now we can just quickly upgrade all the packages. And now we just follow the steps from the Caddy documentation. And now we get the GPG key from Caddy and connect to the stable channel of Caddy. And now we can just update our package repos, and as you can see, Caddy is also standing here, so this will be available now. And now we just install Caddy. And now have a look if it's running. So Caddy is up and running. And in order to have Caddy respond to our subdomain we have created in the start, we need to edit the Caddy file. So we just go for sudo nano and then we go for /caddy and Caddy file. In our Caddy file, we just put a simple config. Basically, we are saying here that the subdomains should be routed to the service running on localhost port 9000. Of course, what we need to do is to restart the Caddy service. The next part we do is to install Docker for managing containers. And here we can just check if the Docker service is running. So this is active and running. And now we can bring up our first container, which will be the Portainer management interface. The run command for Portainer can be found in the documentation. The only thing I have changed here is to change the second port command from, I think, 9443 to 9000. Because Portainer in the standard installation is able to issue its own SSL certificate, and as we are handling this with Caddy, I will just change this one to 9000. So I have this run, and now it will pull down the container. If we go for sudo docker ps, we can see that our container is up and running for 21 seconds now. And now we can just call our URL we have set up at the start of the video. Now you can see this is loading the Portainer interface. As you can see here, we have our subdomain we have configured in the start. Our connection is secure, and we have a valid SSL certificate, which has been issued just right now. That's all done in the background by Caddy, really. So now we will just create an admin user, and let me quickly create a password. Yep. So have my secure passwords, and I will just disable collection of data. And now we can connect to our local Docker daemon. And when we have a look here, we can see the Portainer container is up and running. So that's basically it for now. As I said, this is a very basic video which will enable you to follow later videos of this channel, really, because Portainer will make it very, very easy to get up and running with different Docker containers. So as you see here, we have installed Ubuntu, we have installed Docker, and we have installed Portainer. And within Portainer, we can now manage and install as much containers as we like. And we have installed Caddy as reverse proxy to answer and route our requests. So that's all for now. So have a nice time. See you next time.